Welcome to e-learning. The subject is Vapor Part 3. The problem we have to do today is to figure out if there's going to be condensation in the walls of an old summer house. We have wood on the outside and chipboard on the inside. The relative humidity internal is 42% and the relative humidity external is 93%. And the design temperatures are as stated in DS 418. Today we're going to use the last part of the manual, which is this part here. So we're going to figure out what is resistance to diffusion, what is amount of water vapor passing through, and we're going to figure out the actual pressure in the intermediate layers. As always, we start with writing up the problem. And on the right hand side you can see the important information for internal, and on the left hand side the important information for external. I have listed up the thickness for chipboard and wood, and I have listed up the thermal conductivity for chipboard and wood. So what I have done is I have figured out the sum of resistance, the U value, and the heat transmission, so I can find the temperature gradient. And this is what I'm going to show you in a model of solution. This is what we call a model of solution, and I have figured out what is the temperature in the intermediate layers. And in layer I,1 is 9.9, in layer 1,2 is 4.4, and in the last layer 2,E is minus 8.9. So when we're done, I will fill in for P saturated, which I look up in a table, and for P actual, which has to be calculated. And condensation occurs where P actual is bigger than P sat. So what I have done is that I have looked up in the table with corresponding values of temperature and vapor pressure, and I can see that 9.9 degrees Celsius gives a saturated amount of water vapor at 1240, 855 for layer 1,2, and 275 Pascal for the last layer. The formula to find resistance to diffusion, and the symbol is Z, is to take the thickness of the layer and divide it by the vapor permeability of the layer. And it is so that you must Google the vapor permeability because it can be difficult to find in a table. So what I do now is I calculate the resistance to diffusion for chipboard, and the thickness was 0.01 meter, and I have Googled the vapor permeability for chipboard, and it's 0.0052, and then times 10 to the power of minus 9 kilogram divided by meter second Pascal. Be very much aware of the unit. It has to be in kilograms, meter, seconds, Pascal. So I have used the calculator and I get 1.92 times 10 to the power of 9, and then the unit, Pascal, meter squared, times seconds divided by kilogram. And I do the same to find Z2, which is resistance to diffusion for wood, and I get 10 times 10 to the power of 9, and the same unit. So now I have to find sum of Z, and sum of Z is Z1 plus Z2, and that is equal to 11.92 times 10 to the power of 9, and then the unit comes Pascal, square meter, seconds divided by kilogram. What we have to do is we have to find the amount of water vapor passing through, and as you can see, the formula for amount of water vapor is find the difference in internal and external pressure, and then times it with 1 divided by sum of Z. If you have problems with finding internal and external pressure, look at Vapor Part 2. To find the actual pressures in the layer, I have this equation here, and what it says is actual pressure in layer I,1 equals actual pressure internal minus Zi times amount of water vapor passing through. So what I get here when I use my calculator and fill in the values is that I get 982 pascals, and that is exactly the same thing as internal pressure. So internal pressure is equal to the pressure in the first intermediate layer, and that is because Zi equals 0. I now set up the next equation, and what I'm looking for now is the pressure in the next layer, which is called P1, 2. And as you can see, I have to use the one I just found, that was 982 pascals. I have to use amount of water vapor, and the value is here. And then I have to go to my first page and to find Z1, which was 1.92 times 10 to the power of 9. So I go back, fill in, and what I get is I get 854.2 pascals. Again, I do the same thing. I'm setting up the equation for finding the actual pressure in layer 2, which is the one I just found, minus resistance to diffusion of layer 2 times amount of water vapor passing through. And what I get, filling in the values using my calculator, is 188.8 pascals. In order to check yourself, you will set up the last equation to find out what is the actual amount of vapor external. And remember, Zi equals 0. So what you get is you get that the actual pressure external is 188.8 pascal. And that should be exactly the same thing as you find when you were using relative humidity external times saturated amount of water vapor at -12. As you can see, I have set up the results in a model of solution, and that is of course because then it's easier to compare P saturated with P actual. And if you look, you can see that here could be a problem, because if the relative humidity is going to be higher, then this one will be bigger than the saturated amount of water vapor in layer 1, 2. Remember that condensation occurs where P actual is bigger than P sat.